Hello, and welcome to episode 33 of the Brain Cancer Podcast. First off, I want to say thank you so much for taking the time to tune in and listening to the show. It is about that time of the month where we take a look back on some of the most recent news in the brain cancer community. I've got a few articles here that I want to read to you all and talk about, as well as a more positive article to end the show. I really want to get in the habit of covering these articles and then highlighting a positive article right at the end so that we can always end on a positive note. I want to cover this article, which has a very extra special meaning to me because I've seen just how bad this particular type of brain cancer can be. The article is titled Harnessing a Virus to Fight a Killer Brain Tumor in Kids. A therapy that uses a virus to kill tumor cells can be safely given to children with a rare, incurable form of brain cancer, an early study found. The study, published June 30th in the New England Journal of Medicine, involved just 12 children with the disease called diffuse intrinsic pontine glioma, or DIPG. This particular disease does have a special meaning to me as I lost a close friend due to a DIPG diagnosis. The article continues, but experts said it demonstrates the feasibility of directly delivering the viral therapy to the cancer which forms in the brainstem. Whether the approach can ultimately extend children's lives, however, remains to be seen. DIPG is rare, affecting between 200 and 400 U.S. children each year. There is no cure, in large part because of the nature of the cancer. It arises in a part of the brainstem called the pons, which controls bodily functions as critical as breathing and heart rate. Complicating matters, the tumors are thread-like and interweave with normal brain tissue, making it impossible to surgically remove the cancer. So right now, radiation is the primary therapy for DIPG. Quote, in the majority of patients, but not all, the cancer will initially respond to radiation, said Dr. Susan Chi, Deputy Director of Pediatric Neuro-Oncology at the Dana-Farber Cancer Institute / Boston Children's Hospital. Unfortunately, she explained, that only buys time, as the cancer almost invariably progresses again. Many children diagnosed with DIPG die within a year, and few, less than 10%, survive for 2 years, studies show. This is probably the worst tumor diagnosis we give to families, said she, who is not involved in this new study. For the trial, researchers in Spain, the Netherlands, and the U.S. turned to oncolytic virus therapy, an approach which has been under study for certain cancers, including other brain tumors, with the premise based on the fact that some viruses can infect and kill tumor cells. We have talked about this in a few episodes. There's a lot of promise with oncolytic virus therapy. We had talked about the Zika virus. Virus therapy involves viruses that have been modified in the lab to infect and reproduce efficiently inside cancer cells while leaving healthy cells alone. One such therapy, a genetically modified herpes virus, is approved in the U.S. for treating melanoma. Here, the researchers used a modified cold virus called DNX2401, which has been shown to kill DIPG cells in lab animals. The researchers slowly infused viral therapy into the tumors of 12 children and teens newly diagnosed with DIPG. The patients then received standard radiation. The main goal was to assess the safety of the procedure, according to the researchers, who were led by Dr. Jamie Gallego Perez Larrea of the Health Research Institute of Navarra in Spain. And overall, the most common side effects were headache, nausea, vomiting, and fatigue. 2 children did develop significant limb weakness, which was temporary in one case, which is one of the concerns going into the pons, she said. Unfortunately, most of the children eventually succumbed to their disease, but the median survival at almost 18 months was higher than typically seen in DIPG. She cautioned, however, that it's too soon to draw conclusions. Some children with DIPG do live that long, she noted, and it's not clear that the viral therapy itself, as opposed to the radiation therapy, extended some kids' lives. On the other hand, she pointed out, 2 children were still alive past the 30-month mark. That included one child who was progression-free after 38 months. The early findings are, quote, encouraging. The approach was well tolerated, and the virus went where it was supposed to. She said the survival findings should be interpreted with caution since the trial was primarily designed to assess safety. Researchers initially believed oncolytic viruses might work by directly killing tumor cells, replicating within them until the cells burst. But over the years, studies have shown that the process may also trigger an immune response to the cancer. I think it's part direct kill and part immunotherapy. Normally, she explained, the immune response to DIPG and other types of gliomas is suppressed by both the cancer and standard treatments for it. When tumor cells are infected with oncolytic viruses, though, they send out signals that can draw an immune response. Both doctors pointed to some key questions in the future. Can virus therapy be combined with other types of treatment to improve DIPG survival? And are certain patients more likely than others to benefit from any one oncolytic virus? Of the 2 children in this trial with the longest survival times, one had a tumor with a gene mutation that has been linked to relatively better survival, the researchers pointed out. This was not, quote, obviously a home run in this early trial, but she added that in the general way to progress cancer research is incremental steps forward. Our next article also does cover DIPG, and it also has a focus on glioblastoma. New research from the UVA Cancer Center and UVA Children's Hospital could enable CAR T Cell Immunotherapy to treat 2 forms of brain cancer, which are now almost inevitably fatal. The discovery could lead to better treatments for other solid tumors as well. The new research identifies vulnerabilities on solid tumors, including the brain tumors glioblastoma and DIPG, that CAR T Cell immunotherapy could attack. Both of these brain tumors lack effective treatments. Only 6.8% of patients with glioblastoma survive 5 years after diagnosis. Children with DIPG live, on average, only 9 months after diagnosis, despite intensive brain radiation and chemotherapy. Researchers have struggled for decades to find new therapies to treat these cancers. Quote, our work strongly suggests that CAR T cells could be highly active in treating glioblastoma and DIPG, said UVA researcher Daniel Lee, MD, a pioneer in the field of CAR T cell immunotherapy. This CAR T cell therapy could be a game changer for deadly brain tumors, much like a different CAR T cell product shifted the paradigm for how we treat patients with relapsed leukemia and lymphoma. Chimeric antigen receptor T cell therapy weaponizes our natural immune cells to make them more effective cancer killers. It extracts a small number of white blood cells called T cells from a patient's blood, genetically modifies them to kill the cancer, and then those cells are then infused back into the patient where they replicate into a vast army of cancer killers. The entire process takes about 2 weeks, as opposed to other processes which can take months. CAR T cell immunotherapy has had significant success in battling blood cancers, but it has been less effective against solid tumors. Lee's new finding could enhance its ability to target these tumors that now resist CAR T cell treatment. His new work identifies specific targets on glioblastoma and DIPG cells that the immunotherapy could exploit. When tested in mice, the approach was very effective. The tumor shrank or disappeared, and the weaponized immune cells proved long-lasting. The approach also avoided side effects that have previously hampered its use in people. Particularly notable was the approach's effectiveness against DIPG, a cancer that threads itself through the brain, making it extremely hard to treat. Lee's immunotherapy approach shrank the tumors and improved survival among lab mice. The scientists note that the cancer's invasive nature likely will continue to pose a challenge, especially when the cancer's tentacles extend into the vital areas of the brain, but the researchers were encouraged by the promising results. Many solid tumors share the same vulnerabilities Lee's team identified in glioblastoma and DIPG that suggests the results could have wider applications for solid tumors. Quote, "We have already begun to see if we can use this same therapy to treat other tumors like melanoma, breast cancer, and the pediatric muscle tumor rhabdomyosarcoma in the lab," said Lee, a pediatric oncologist at UVA Children's and UVA Cancer Center. "My team in the lab is working incredibly hard to understand how we can bring new and safer CAR T cell therapies to the citizens of Virginia and beyond. Our findings in brain tumors represent a huge leap forward in doing just that, but there is much more work to be done." I wanted to talk about these two studies because it shows how invasive DIPG and glioblastoma are, because they can burrow into our vital areas of the brain and avoid being able to fully be removed during surgery. They can lie in wait while also becoming resistant to temozolomide. These diffuse tumors make surgery essentially impossible because they spread out so thinly you can't just go in there and remove the tumor. So we need to find ways that can attack the cancer cells while leaving all of our healthy brain matter there. Obviously, there's still a long way to go, but without these studies, we wouldn't be at the point where we're still moving forward. And in the same vein, I want to talk about this study that is titled Light-Activated Photoimmunotherapy Could Enhance Brain Cancer Treatment. An innovative light-activated therapy developed at the Institute of Cancer Research London could help detect and treat an aggressive brain cancer type, a new study shows. The photoimmunotherapy contains a special fluorescent dye with a cancer-targeting compound, which together boosts the body's immune response. In studies in mice, the combination was shown to improve the visibility of cancer cells during surgery, and when activated by near-infrared light, to trigger an anti-tumor effect. The treatment, studied by an international team of researchers from the ICR and the Medical University of Silesia, Poland, could help surgeons remove brain cancers like glioblastoma more effectively and boost the body's response to cancer cells that remain after surgery. Glioblastoma is one of the most common and aggressive types of brain cancer. As patients and caregivers, we already know this. And it continues, surgeons often use a technique called fluorescence-guided surgery to help treat diseases like glioblastoma and other brain cancers, which uses dyes to help identify the tumor mass to be removed during surgery. But due to these tumors growing in sensitive areas of the brain, like the motor cortex, which is involved in the planning and control of voluntary movements, glioblastoma surgery can leave behind residual tumor cells that can be very hard to treat, and which mean the disease can come back more aggressively later. The new research, published in the journal BMC Medicine, builds on fluorescence-guided surgery using a novel technique called photoimmunotherapy, or PIT. This treatment uses synthetic molecules called affibodies, small proteins engineered in the lab to bind with a specific target with high precision. In this study, the researchers combined an affibody created to recognize a protein called EGFR, which we are familiar with, which is mutated in many cases of glioblastoma, with a fluorescent molecule called IR700, which is used in surgery. Shining light on these compounds causes the fluorescent dye to glow, highlighting microscopic regions of tumors left in the brain, while switching to near-infrared light triggers an anti-tumor activity that kills tumor cells. The researchers tested this combined molecule or conjugate, known scientifically as, get ready for this, ZEGFR 03115 IR700 in mice with glioblastoma. They could see the cancer-targeting compound fluorescing in the brain tumors during surgery just 1 hour after administration. Shining near-infrared light on the tumor cells then activated the anti-tumor effect of the compound, killing cancer cells. Scans of mice treated with the compound showed distinct signs of tumor cell death compared with untreated mice. Photoimmunotherapy also triggered immune responses in the body that could prime the immune system to target cancer cells, so the treatment could help prevent glioblastoma cells from coming back after surgery. As well as being a possible future treatment for GBM, the approach used for ZEGFR 03115 IR700 could also be adapted against other targets in other forms of cancer using new affibody molecules. Researchers at the ICR are now also studying the treatment in the childhood cancer neuroblastoma. The study leader said, quote, "Brain cancers like glioblastoma can be hard to treat, and sadly, there are too few treatment options for patients. Surgery is challenging due to the location of the tumors, and so new ways to see tumor cells to be removed during surgery and to treat residual cancer cells that remain afterwards could be of great benefit. Our study shows that a novel photoimmunotherapy treatment using a combination of a fluorescent marker, affibody protein, and near-infrared light can both identify and treat leftover glioblastoma cells in mice. In the future, we hope this approach can be used to treat human glioblastoma and potentially other cancers too." I really think this is an innovative type of immunotherapy and treatment. We know that we have to really think outside the box if we want to be able to effectively treat glioblastoma and other aggressive types of brain cancer. We have the blood-brain barrier, which is a great thing that we have, but it's also a barrier to effective treatment. Using infrared light does not have to worry about the blood-brain barrier. Much like DIPG is a rare pediatric cancer, we have the FDA granting rare pediatric disease designation to Paxilocib for the treatment of patients with atypical rhabdoid or teratoid tumors, AT/RT, in rare and highly aggressive childhood brain cancer, according to the Casia Therapeutics Limited. The basis of the RPDD comes from the promising preclinical data for Paxilocib in AT/RT presented by Jeffrey Rubens, PhD, and colleagues at the 2022 American Association of Cancer Research annual meeting. Previously, Paxilocib was granted orphan drug designation for AT/RT by the FDA on June 16, 2022. Quote, "This is the second time that Paxilocib has been granted RPDD, and it demonstrates the importance of childhood brain cancer in the overall Paxilocib development program. Brain cancer is the most common cause of cancer death in children, and outcomes in many forms of childhood brain cancer have not improved in decades. We hope very much that Paxilocib can make a difference to families affected by both DIPG and AT/RT, and we will be working closely with clinicians, researchers, and FDA to determine the optimal way to move the drug forward," stated James Garner, MD, Chief Executive Officer of Casia Therapeutics, in a press release. Paxilocib was also granted an ODD for the malignant glioma indication, which includes glioblastoma in adults and DIPG for pediatric patients. Currently, the Pacific Pediatric Neuro-Oncology Consortium is leading a Phase 2 study for the DIPG indication. The ongoing Phase 2 clinical trial of multiple drug therapies includes Paxilocib. An estimated 216 patients will be enrolled in the study and randomized to receive one of 3 treatment regimens involving combinations of radiation therapy, the drug ONC201, and Paxlovid. The primary endpoint of the study is progression-free survival, also known as PFS, at 6 months, and overall survival, also known as OS, at 7 months. Other exploratory endpoints of the trial include confirming the blood-brain barrier penetration by ONC201 in DMG, assessing changes to immune cell infiltration in DMG tumor tissue, and toxicity. Initial data from the study is expected at some point within 2023. Additionally, a phase 1 study of Paxlovid in DIPG is nearing completion. The study is led by St. Jude's Research Hospital in Memphis. The first phase of the study is a dose escalation phase, which will consist of patients who will receive Paxlovid in doses of 21, 27, 35, or 45 milligrams per meter squared after they have completed radiation therapy. The primary endpoint of the study is to estimate the maximum tolerated dose and recommended phase 2 dose Paxlovid after standard radiation therapy. Secondary endpoints include overall response, duration of overall best response, PFS, and OS. Data are expected to be published at the end of 2022. June of 2022 certainly had some promising and encouraging articles and studies coming out for DIPG, GBM, and other aggressive brain tumors. I didn't initially plan to have 3 articles all focused on DIPG, but I thought it was something that could tie in all 3 articles. It can be difficult trying to narrow down which articles I want to talk about, but because DIPG is so universally fatal and is so prevalent in pediatric cases, although it's rare, no kid should be having to go through the treatment for DIPG. It also occurs in adults, as I have known someone who was affected by this and became one of my closest friends. I am super encouraged by some of the studies that I've been reading, and I will definitely be following up with the studies that I just talked about in this article. I will also try and update everybody else. As we get to our final article of the day, it brings me back to my point that there is no such thing as a benign brain tumor. This article, entitled "Woman Who Lost Her Sight Through Brain Cancer Prepares for Sunderland Triathlon." A woman who was left visually impaired after having surgery to remove a brain tumor is preparing to take part in a Sunderland-based triathlon. Karen Eggleston's grade 1 olfactory groove meningioma was discovered after she had suffered a seizure at home and went into cardiac arrest in June 2020, flatlining for about 10 minutes. She had been exhibiting strange behavior attributed to workplace stress, but the shocking discovery was not made until brain scans were carried out to check for any damage sustained during the 10 minutes her brain was without oxygen. Unfortunately, this is the story that so many of us go through. We think it's workplace stress or relationship issues or any number of other reasons, but then we find out after something big happens like a seizure that it was the tumor causing all of this, not any other outside factors. When she came to a week after having a craniotomy, she had no memory of the 7 months leading up to her collapse, including the emergence of the COVID-19 pandemic, and found herself completely blind in her left eye and visually impaired in her right eye. Now the 51-year-old HR and organizational development consultant from Westerham in Kent is preparing to compete in the Sun City Triathlon in Sunderland on the 7th of August, swimming 750 meters, cycling 15 miles, and running 3 miles, all in aid of brain tumor research. She will be participating alongside her brother, who is a math and science lecturer, who will be her guide for the challenge. The 49-year-old is a member of the Sun City Tri Club and encouraged his sister to get involved. Karen said, "Before I had my brain tumor, I did some triathlons and I was trying to get fit after my operation. My brother and I were setting ourselves little challenges last year. In June, we did 10 hours of each of the 3 disciplines while sticking to the rules of lockdown, and sometimes we were training without leaving our house, so this year we decided to do a triathlon. Being visually impaired will make Karen's challenge tougher than most, so she has been practicing how best to do it." She added, "I did a practice session with my brother in the pool. He swims in front, and I touch his feet as he goes. On the day, we will be swimming in the harbor, and I will be assigned my own lifeguard. I've been practicing the cycling on a static bike, but we will be hiring a tandem one for the race. Running is harder for me to practice, but there's a little park near me where I go knowing that if I run around it 4 times, that's roughly 3 miles. On the day of the triathlon, we'll run along the promenade and down to the seafront where there are a lot of curbs. My brother will run slightly in front. We will be tethered, and he will shout obstacles to me. It's daunting, and as the weeks are ticking by, I'm thinking, oh my god, we've got only a short amount of time to get myself up to speed. The swimming's going well, and the cycling's just about there, and we've started doubling up training sessions. It's the challenge of doing them and the run together, but if I can survive the swim and the cycle, I can walk the run. I will run as far as I can, but if I need to walk, then I know I can. The whole purpose is to finish." Although part of Karen's tumor had to be left in, it is thought that removing the rest of it cut off its blood supply, and with the 3 radiotherapy sessions she has had, it seems to have disappeared. She received the news that she was, quote, all clear just before Christmas, and began working to raise awareness and funds for brain tumor research. "Before my diagnosis, I didn't know anything about brain tumors, but now, having been thrown into this world, I understand that so many more people are affected by this disease, certainly more than you'd imagine. My aim is to make the journey for future brain tumor patients easier than mine was. I was lucky to survive. It was touch and go that I did, but it's left me with problems, so I want to raise awareness and make sure people are getting treatment early enough. It's the whole payback thing for me. I was lucky, so I've got a moral duty to give something back. Brain tumors kill more children and adults under the age of 40 than any other cancer, yet just 1% of the national spend on cancer research has been allocated to it. Note this is in the UK, and I'm based in the US, and I'm not sure exactly the percent of funds that are spent on brain tumor research and treatment. I do know that it is fairly low." What she said is so true, and I feel like I'm in the same situation. I didn't know anything about brain tumors or brain cancer before I was diagnosed. It's not something that many of us would have been reading about or learning about, but once we're thrown into this community, it can be tough trying to get a handle on everything that's going on. I'm so thankful for having such a great brain cancer community, and I've met so many amazing people through this that I don't really want to imagine a life where I had never met some of these people. That might sound awkward, and it really is hard to explain, but I wouldn't want to imagine my life without some of these people. Your world really is changed, and it's so difficult being the person who has to try and explain it to those around us. It can be frustrating when we know we can do things, but our brain just doesn't want to cooperate. This does bring us to the end of our episode, and I want to say thank you so much just for tuning in and listening. I know I say it all the time, but it really, really means so much to me. And I hope that I can at least be helpful for somebody somewhere. Like I said before, this is something I enjoy doing so much. I'm lucky in so many different ways, and I always want to be able to help people and give back to the brain cancer community. We've lost far too many good people to just sit back and wait for effective treatments and cures to come in. That's why we have to push for more government funding for brain tumor research, working with different charities like the ABTA to support new and existing patients and caregivers. It is just as difficult, and sometimes can be more difficult, for the caretakers that we have. I am not sure what our next episode will be, but I do have a couple that I really want to record soon. And I definitely want to be able to get one out for Glioblastoma Awareness Day. I'm going to try to. I'm not exactly sure what I want to talk about. It might not be a long episode, but we'll figure it out. That's pretty much how I live my life. We'll figure it out, and we'll go from there. Make sure you follow the page on Facebook, where I post every single day at facebook.com/braincancerpodcast. Give the podcast a follow on Twitter at braincancerpod. Feel free to email me at any time at braincancerpodcast@gmail.com. Be sure to subscribe, like, follow the podcast on whatever app you're using. You can also leave a review on the Facebook page if you would like. But more important than any of that is me just saying thank you. I will be back soon with another episode, and I hope you all have a great day or night, and I will talk to you again soon. Bye.